First, I really appreciate, just like Tim has pointed out, a lot of you have come from very long distances. So I'd like to get a sample. How many people came from outside the US today? Wow, nearly half the audience. How many are from the Stanford community? This year we decided to also invite students, faculty, and staff, and so on. So about 3 or 4? No, actually, quite a dozen. We also extended the same, this is a dangerous question, how many people are from Berkeley? See, that's why they're at the back. The thing is, you're here at the invitation of the dean, Sujay King Liu, who's a classmate of mine. And as you probably know, her PhD is from Stanford. Did you bring the axe, though? Did you follow the instructions? No? Okay, they have the axe this year. Okay, so with that out of the way, I've cleared the minds. I'm going to talk about something that is actually a very hot topic. But it's hot, but it's actually, people don't agree on what the heck is an agent. We've used the term agent for a very long time. But more importantly, in the nature of this conference, it's about industrial AI. So hopefully by the time I'm done, you'll carry away at least one thing, which is going to be that it turns out generative AI is actually more important, more significant to the industrial physical world, in my view, than it is to the digital world. And some of you may know I have some creds from the digital world. I helped launch Gmail, right? So when I say this is more significant over there, it's probably true. First, I want to start out. This is something that we all know, right? But I want to put it on a slide. America today, we face a deindustrialization crisis. This is actually economic theory that we've pursued for the last 30 years, right? And then we find one day that actually, no, we actually still need to make things. We can't really just outsource it to everyone and suffer some geopolitical risks. But one thing that some of you may be very intimately familiar with, but others are not, is that we have an experiment in progress, right? And that is TSMC. We actually have some guests or some partners here from TSMC. So you know this story as well or even better than I do. We have an experiment of TSMC being launched, new fabs in Kyushu with pretty much the same or even less budget than the one in Phoenix. And I'm not going to spend the whole talk going over all the details of this. But I hope I don't offend anyone by pointing out that the right-hand side has been a failure and the left-hand side has been a huge success. And the only variable is the people involved, right? So that says something, but the main thing, some have referred to it as culture, but I think of it specifically as the lost critical expertise. It's quite interesting at an AI conference that I say what's really important is actually what's in your heads, what's in your brains still. Okay. And that's going to be true for a very long time, in my view, right? AI is not going to replace us. It's going to enable us so that our expertise become even more important. So that's the message that I want to carry here. You may have seen this Y saying that crisis in Chinese, the word is crisis and opportunity, right? Is luck, right? So America also has a reindustrialization opportunity. And in that sense, we're not going to be bringing low-end manufacturing back. It's going to be leapfrogging, right? So in the sense, we talk all the time about Asia and the developing world sort of leapfrogging, going from copper lines directly to mobile and so on. So America actually has an opportunity to leapfrog all of the manufacturing burdens, right, that has not taken advantage of AI. But AI can help here. So I want to go some of you may have seen me do this, right? And you look at the screen, what it is a survey that essentially measures technology optimism, right? Some of you may have heard the term tech bros here in Silicon Valley are usually techno-optimists, right? But technology optimism is a thing, right? And I think it's a good thing. And it's no surprise, I think. I decided to take this data of this survey and I plotted versus country. And so you can, GDP per capita. And it turns out first there's a strong correlation, right? Higher GDP countries, this chart is, okay. This is AI optimism, I'm so sorry. Okay, the headlines is switched. Okay, ignore the headline, listen to me and look at the chart. Technology optimism goes up with GDP per capita. That's no surprise because Google, Facebook, and so on, we are in the rich countries, we can take advantage of that a lot more. Everybody's optimistic, but some are more optimistic than others. The surprise perhaps is that there's a correlation at all. And you already saw the last slide when they did the same thing for AI, but AI is the opposite. That's weird, right? The correlation is even stronger, 65%, in terms of 65% of the variation is explained by the line alone. That's the 2022 GDP per capita and so on. You notice the United States, we're less optimistic or more pessimistic than China, India, Peru, and so on. And that means something, because if you're more optimistic about something, you're more likely to apply it. And if you're going to more likely to apply it, you're going to win more with it. So that's something important to put in mind, keep in mind. I'm not going to go through some analysis of it, other than to share with you this interesting thing. So I decided to take this chart and I plot the residual, right? So think of that as optimism, but an extra optimism. You can see some of the curves here are more optimistic than others. Like for China, unreasonably optimistic, way up here. And over here, like France is always below the curve. And if you look at the residuals here, Saudi Arabia is extra optimist, right? That is above the trend line. And it's not surprised that France is like this on every chart in terms of optimism. That's okay. I grew up speaking French before I spoke English. I decided to correlate that, right? If you look at these economies that tend to be lower GDP per capita, it turns out that's because they've been still making things. They've been doing so-called lower value added stuff versus the advertising, the marketing that we tend to do here in the US. So what do you think it'll look like if we took that chart and we correlated against the industrial content of the economy, right? This is as a percentage of their GDP. Do you think countries that are still more industrial would be more or less optimistic about AI? How many people think they'll be more optimistic? How about less? Okay, let's take a look at the data. Higher the economy is still making things, the more optimistic they are about AI. It's from the same data set. So that says something, right? That says that Vietnam, Japan, China is going to be more optimistic and therefore more likely to adopt Gen AI than we here in the US. And in fact, how many people have seen some of the recent data where they survey businesses? Like how many, is your business already adopting some kind of Gen AI in your day-to-day workflow? The number coming from China is 85%. It's amazing. I was going to say it's scary, but it's amazing, right? And as we may pride ourselves on creating stuff, but it's the people who use it, the people who scale things, right? Like the TSMC problem is not a science problem, it's a people problem. We cannot scale that, right? Battery manufacturing, Panasonic, my Panasonic friends here, we're working with Tesla Gigafactory. It's a scale problem. You hear announcements of amazing battery technologies all the time. None of them scale, right? It's the scaling that matters the most to the economies. So let's keep this in mind. I decided I like playing with things, so I decided to just impute a model that for every % optimism above some level, then that may give you, in this case, I just say 0.2% on the GDP impact. And simulate that out 10 years to see what happens. You can see the 2022 GDP here, the gray, where the US is, right? Still very much larger than China. The other data points is quite interesting, but we don't have time to go over. But just because of this extra optimism, right? With the 2032 output of China is going to tower over the US. And along with that, standards of living and technology and everything else. So anyway, I think it's something to think about, right? Just the optimism and the adoption of technology alone. Okay, but let's get more specific, right? I think I'm putting some statements here that some of you may already be familiar with quite intimately, but to others that you may be surprising, so I'm going to go over them one by one. Generic LLMs, right? Maybe this is the first time you hear the term generic, because I'm going to talk about something that isn't generic. But think of OpenAI, Google, and everything else as generic, right? They know a lot about many things, but they're broad, but they lack domain-specific knowledge. And that's actually quite important. We all know about how many of the responses can be hallucination. And people are trying to fix that in the model themselves. More importantly, people are trying to fix it in the systems that leverage these models. And something that people are starting to think about more, particularly, again, in the industrial applications, is that the very probabilistic nature of these LLMs are actually quite undesirable, right? You can run these academic tests in your paper and say, wow, accuracy 90% and so on. But these are almost cherry-picked because in industrial and in other many business applications, you need the answer to be the same every single time you ask that same question. It's a business process. You don't want creativity. You don't want the LLM saying, every once in a while, I'm going to mix it up. So the inconsistency and the shallowness of the answer. I like to compare a fresh PhD with somebody with 20 years of experience. Fresh PhD is very useful. When you ask about dichlorosilane in semiconductor, they can tell you all the possible uses and so on. Then you say, what do I do with this problem? I don't know what to do. I'm going to repeat everything that I've learned. But somebody with 20 years of experience, in that case, what you need to do is increase the flow rate to 200 SECM and so on and so forth. So think of these wonderful, amazing LLMs as fresh PhDs, right? They're amazing in and of themselves, but they have no domain-specific knowledge, and they don't have the experience that the people in the room here do have. And that matters to systems that we build, right? So domain expertise is actually the key to success in the physical world. And this is not something that I just reasoned through these slides. This is something that when I was helping to run global industrial AI at Panasonic, we actually ran into problems that AI could not solve without consulting with the one or two experts that Panasonic has in refrigeration. And with that, we can actually solve the predictive maintenance problem. The opportunity is that domain expertise, we always knew it was valuable, but it's been the reason we don't use it. Think about this, okay? A lot of time in technology, we do something, and we don't realize it's actually a bug. It's not a feature. Like cyberspace is a bug, not a feature. The reason we had to coin the term cyberspace is because our computers couldn't reach into physical space. So same thing, relying exclusively on data is actually a bug. It's because we couldn't use knowledge, because it's too difficult to encode. But with Gen AI today, suddenly we can speak to our machines, and they understand us. I think that's the biggest revolution. It's not that they're smart, it's that they know enough to listen, to understand. For the first time, we can actually easily interface with the analog world, right? Natural language, vision, and so on. That's been very difficult until now. So that's the key opportunity. So with that, I want to give you this vision. Actually, it's a product that we're building. It's going to happen pretty soon. Whoa, where are we? Okay. Essentially, a lot of us work on. So I want to talk about this model of expertise in terms of capture and apply. You capture the expertise and you apply. It sounds very obvious, but you look at the landscape, across the landscape today, because of this very data-driven point of view in machine learning, we don't think about the capture as much. The capture is the dirty part, right? We think about the apply part, the algorithms. But how do you then do the same thing in the knowledge age? How do I capture a Samsung expert's knowledge and put that into my system, right? A lot of the activities today assume that these documents somehow magically exist. And then when you look at the document, they tend to be manuals and so on. But the knowledge, the experience of having gone through the 20 years of work at a facility in a fab is not actually in those documents. So I want to talk about that capture. So think about this as a fault diagnosis AI system. This is actually a real use case that we're working on, right? But the first step has to be capturing the knowledge of somebody who is actually about to retire. And I'm not saying that figuratively, I'm saying that actually. There's somebody in the audience here that's involved in this project. So let's start talking. Okay, go to the next step. Okay, so we can have a process where I'm saying a wandering etching process, fluctuate even a little bit. This is what I mean. For the first time, I can get an expert to sit down with me, with the machine, and just start dictating. Just start saying extemporaneously, this is what. And we went through this process, right? And then with Gen AI, we can actually say, okay, is this what you said, right? That's what I mean by the easy part. Okay, let's go to the next step. Okay, yes, correct. Okay, and then, now we save that, and then we can now structure it automatically, right? Okay, we can put it in some structured form. In this case, it's a YAML file. But you can imagine that could be some other symbolic language. It could be Python, it could be anything, right? Where you can run through this process many times, right? And this is what I mean by encoding the knowledge, okay? And then you can go from there to another transformation. You can build a diagnosis program, okay? This is a simple example. You can say, yeah, I'm just going to hire some Python programmer to do that. But you can't do that for free-flowing kind of sharing of knowledge and rules and so on. And you can do that, and you can simulate and see the result. Right. So now you have one piece of knowledge that is now operationalized, right? It can essentially say, detect that the risk of non-uniformity is very high because of fluctuations in the plasma power. Okay, any questions or comments about this? But you can repeat this process, right? We can automate this now. And I think that's the revolution. Okay, so with that, I want to talk about the paradigm behind this. So the way you can think about this is that, remember earlier I referred to the term generic model, right? Those are models that know a lot, but not specifically about my process. It's not it's dumb. It's not that it's dumb. It's not specialized enough to my language, to my system, my processes, and so on. So what we want to have is an expert model. And earlier Tim spoke of Semicon, and there's a booth over there, a result of AI Alliance work. And then you have this expert model, and remember, this expert model can ladder. You can have an industry expertise, and then you can have company-specific, tool-specific, even process-specific, right? And that's the opportunity. But even that is not enough, because models, as they go, do not have something that many of you may have heard of, planning and reasoning capabilities. The ability to loop over and reason through a process or a problem. So you'll see this emerging. So I'd like to share with you a bit of details about Semicon, as has been spoken. This is an effort under the AI Alliance. And hopefully throughout the day today and tomorrow, you'll have an opportunity to talk with some of the AI Alliance representatives here today that advocates for open science and open development. And the Alliance has a particular methodology, or an MO, that is we want to actually output things, not just sit there and talk about nice things. So Semicon is one of those output. Right? And it's built on Llama 3, which is an open model as well. Right? And what's the most interesting thing about building something on open? Right? The slightly counterintuitive thing is because it is open, you here in the audience that have very secret, very competitive processes, you can take that open model and add your, thank you, I have that, and add your own knowledge without having to pay a tax back to somebody who's a proprietary model underneath. So this openness is very important to innovation, right? It means you can just, if you want to contribute back, that's great. But if you need to build something proprietary to TSMC or Tokyo Electron or Applied Materials, you are free to do so. I think that's what we want to promote. And this is, for those of you that don't come from the semiconductor industry, this is highly unusual for semiconductors, right? If you come from software, you say, oh, that's a big deal. I've been doing this forever. But in semiconductors, even the vendor and the customer have a clear wall between them. You may not know what I'm using your equipment for, right? And so having the ability to somehow share so that we can compete on a higher plane rather than at the lower levels. So this is an example applying, actually Semicon being used to apply domain-specific agents to a semiconductor manufacturing process. In this case, it's an RAE etcher. Okay, and here it's using it for, I believe it is for process engineering. Okay, so I already talked about AI Alliance. Take a look at the website, thealliance.ai. Okay, today over 100 members already. And I'm quite proud of the fact that it's not just US companies over here, but also a lot of the industrial companies from Asia and certainly very well represented by our Japanese members. So agentic AI, I mentioned planning and reasoning. I'll give you one example. This is not the only model, but one example what we mean concretely, because you hear the term planning and reasoning all the time. Agent, in the meaning that I'm using here, and you will see more and more people converging toward this in the generative AI era, right? We want to use the word agent to mean something that is goal-oriented. And essentially, it has the property of planning and reasoning in order so that it can iterate over a particular problem statement. And then it says, have I solved that problem yet? I haven't, then let's figure out how to iterate and go there. And models, as they are today, LLM by themselves, don't have that capability. Okay? And to the extent that you see ChatGPT or others that seem to have this, it is actually because they have put a planning and reasoning framework around it. Right? The model themselves don't do that. So one architecture that we use at Itomatic is what's called hierarchical task planning. That is, given a task, break it down into subtasks, right? And then you ask your system, not the model itself, but you ask the system says, given that, can I solve this task in one step? And if the answer is yes, go ahead and do it. If the answer is no, break it down further. So pretty straightforward in terms of that planning idea. Within each task, then, there's a reasoning loop, right? And you can use different paradigms again. This one is an OODA loop, right? How many people are familiar with the term OODA? Great, okay, so I don't have to go over that. If it's good enough for jet fighter pilots in deadly situations, it's probably good enough for a lot of process engineering work. But you go through this process of observe, orient, decide, and act. You observe the environment, the resources that you have available, and then you orient, you decide, do I have sufficient information, resources to solve the problem? And depending on the answer, you decide what to do next, then you take the action. And then now 1 second or 1 day has elapsed, the world has changed, you go through that loop again. Okay, so that's the OODA loop. So this is one very significant representation of the planning and reasoning. And I don't know if there's going to be a talk with a colleague of mine, Vinh Leung, is the leader in a project called OpenSSA, stands for Small Specialist Agents. And so you can you look for OpenSSA, and there's an implementation of this. And again, it's open source, so you can download and use it. And here, I just want to highlight many of the guests here that have participated in this revolution alongside with Itomatic, right? And these are real-world use cases that are either in the production or in development today, right? And so I say this like it's nothing, but it turns out in Silicon Valley, in the digital world, there's a lot of startups that are struggling to find problems for which Gen AI is a solution. So I've been around long enough to say, this is very weird. The industrial companies are the first adopters of a technology. That's never happened before, right? Because industrials are slow, maybe from Silicon Valley perspective, stupid. I can say that because I was Panasonic too. But it turns out it's not. It's because the industrials have been working on much more difficult problems. When I was at Google, I like to say when I was at Google, when I make a mistake, you click on the wrong ad. But at Panasonic, if I make a mistake, somebody dies. So it's very reasonable, it turns out, that these industries have been moving more carefully. And there's something about generative AI, and I think it lies in the fact that you can easily capture all of that domain expertise, all of that pent-up demand with this technology. It's different this time, essentially. And that's why the industrial world, I believe, will leap ahead in terms of the adoption of generative AI. Okay? So the call to action here is essentially don't fall behind, right? Lead the industrial AI revolution. Do it with us. Do it with this paradigm, this base LLM model with the expert, and with agents above that. And if we do that, yeah, maybe, okay? So I basically did the same analysis and said, what if the US was equally optimistic about AI? This is what the future is going to look like, 2032, right? Okay, so essentially that's the additional GDP growth that comes from AI-adjusted delta alone. Okay, so I think that I would like to leave you with this vision for those that care about the development of the US industrial world. Okay, so what the world wants and what industrialization needs is to capture and apply domain expertise, number one, very specific. We can use help from AI, right? And we can use a lot less fear and a lot more optimism. And I'd like to leave you with that thought. Thank you.
Thank you, Dr. Wen, for the insightful talk on AI optimism across the globe and the French's pessimism, specifically, sir. Definitely a takeaway for me. But before we let you go, we'd like to see those in the audience if you have any questions for Dr. Wen.
Why are domain-specific LLMs not sufficient? Why do we need to combine them with agentic AI?
Oh, okay. I'm sure everyone heard the question. Quite simply, it's because LLMs or models in general don't have planning and reasoning. More generally, you think about models as one-pass things, right? There's an input, there's process, and there's output. That model, that paradigm alone tells you that it cannot solve problems. You still need something outside of that loop to say, okay, given that now the world has changed, what do I do about it? There has to be a recurrent loop coming back. And that loop is the planning and reasoning loop. Now, if you build a system that has that built in, then that system can do the planning and reasoning. But LLMs, as they are built today, don't have that loop.
So it's hard to imagine that LLM is the asymptotic limit of what AI is going to look like. And you can look at the agentic workflows as basically a confession that you need a lot of crutches to make LLM do something useful, reliably, and robustly. So what do you think is going to be the next step after LLM, post-LLM, if you will, post-agentic LLM even?
That's actually a very sophisticated question, so let me try to frame it in the way that I understand it. In other words, all of this coding that does the planning and reasoning outside of the model, that seemed like a crutch, right? Because with these LLMs or with these models, it's magic. We just feed a bunch of data into it and intelligence emerges. It doesn't feel good to add this extra layer into it. Let me accommodate that first, and then let me deconstruct it later. So the way I accommodate it is that, in fact, if you think about the architecture, inherently, it's what I just said, it doesn't have recurrence, right? And recurrence is what gives, there's recurrence in our own brain. We actually, when we solve a problem, we churn it over our mind, right? We even touch the world. I push a car and it moves and then something else happens. So there's recurrence outside the brain as well. So recurrence, or that loop, is inherently necessary. And there are emerging, recurrent models have been around a long time. The reason we don't do it is because it's too expensive, right? And so with more compute, with recurrence becoming cheap, that will be built into models, right? In fact, there's a later model, I forget what it's called, WQKV, that has the property of being recurrent on the training side. Sorry, it's using more transformer parallelization on the training side and recurrence on the inference side, and doing it in such a clever way that the weights are the same. Okay. So the general point is that recurrence will come, and problem solving will come with it, along with models. Maybe that I can stop there, but I'd like to still speak for code. I don't think of what we're doing with planning and reasoning in terms of doing in high-level code is a crutch. I think it's inherently part of the knowledge paradigm. If we can have models that generate this code, then why not just use that at that higher abstraction? We don't have to go all the way down to every neuron all the time. So that's my point of view.
So you showed an interesting example of overcoming the lack of domain-specific knowledge in LLMs by providing an expert, in this case a human expert who's interacting via LLM. One of the challenges and one of the problems I'd be curious to hear your thoughts on how to overcome is that sometimes these experts will come to different conclusions. So two experts may have disagreeing opinions, or even if they have the same conclusion, it may be wrong. And how do you overcome that problem when testing this requires actually interacting with a physical system, which is expensive and has a very long time scale?
Yeah, that's a really good question that comes up all the time, right? And somehow we are always difficult when we come to humans. Well, we accept machines more readily. What I'm getting to is machines also come to different conclusions, right? But we don't worry about that. The reason is we tend to think of them as much more deterministic. Right? The different conclusions themselves. So we no longer, in these systems, we don't think of correct versus incorrect. We think of better versus worse, right? So the difference is, first of all, in how many cases out of 100 does that occur? So let's say there's 5%. So the other 95% is not an issue. We can still deploy that. In those 5%, there are different ways to handle them. In other words, we can say, let's look at the two choices and have another human or another model come in and say, what do you want to do? So these are different options, right? In fact, that's built into the deployment. Today, we're not comfortable enough to go fully autonomous. There's always a human that is saying, here's the recommended next best action. You want to push the button somewhere. Essentially, it's resolved at that level. Okay.
In semiconductor area, the way we capture the domain knowledge is through the standard operation procedure, which is based on statistical knowledge over the years. So there's a SOP and recipe developed, which include the knowledge from expert as well as from the machine. Why don't we use that as a way to capture the knowledge instead of going back to the expert? And there are so many SOP already readily available. Make the way you try to capture the knowledge easier.
Yeah, that's a good question. So the answer is not either or. The answer is we have been taking advantage of all those SOPs already. Semiconductor companies are very advanced in having all of these things, right? But even that is not enough. There's stuff that sort of escapes these things. So for example, I had one conference. So when we sit down and do these interviews, when we start out, we do it just manually without these tools. What I always say is that I'm not interested, or don't talk about stuff that's already been documented. It's quite rich. But tell me about a problem, an incident that happened in the last 5 years when for some reason, and I say don't be embarrassed, don't be too humble. I said, when only you, if you were not there, it would not have been solved. Tell me about that. And really interesting stuff emerged. So one example is one gentleman from company, facility in Phoenix, talked about yield problems that took a long time to trace back to pressure fluctuations in a chamber. And then they didn't know why that was happening, but because he's a process engineer, but he also talks a lot to the facilities people. And then he remembers that there was a piece of equipment that used the same gas line that was installed like just a week earlier, right? And they weren't careful with it, and that led to that fluctuations. Would they have figured that out by putting 10, 20 people together? Yeah, it may have taken a week, a month. But because that gentleman was there, in his mind he said, okay, take a look at that, and it was solved quickly. And that piece of knowledge was not in the standard operating procedure. Yeah, because basically now we have a person who knows both facilities as well as process. Yeah, good question. And that's why I mentioned earlier, we have all these documents that we're ingesting. But I think that the grand opportunity is the stuff that is not in those documents already.